All right. Okay. Do that later on. I will teach you how to do it. Okay, let's look at the question here. Okay, come. Listen here. Are you ready? Good. Thank you. Okay, so let's look at the easy question first. Let's look at the easy questions first. Okay, so let's. You did not do any of this. No idea how to do or what? Hmm? No idea how to do or what? Answer my question. You have no idea or what's stopping? No idea. Okay. Okay, then so basically you have this fraction and then you divide another fraction. Okay, so what you normally do when you divide when you have a division for two fractions. So let me just give you a simple one first. So let's say you have half divided by 6 over 3. How do you do this kind of question? Okay, so when you divide by a fraction, right, so it's as good as you times, but you flip the, the, the second fraction up and down, right? Yeah, okay. So you flip it up and down, so 6 comes down, 3 goes above. Okay, so what you end up with after this, then you just numerator times numerator, then denominator times denominator, right? Yeah, so it's 12, right? And then after this, you have to check whether this is simplest form. And by the way, there is a very easy way for you to check whether it's a simplest form is just use a calculator. So can you use a calculator? 3 over 12. So to check whether this is simplest form. Yeah. Can I ask why this is why you have to express it in simplest form?
Because
Mm.
the simplest form is like the final answer.
Yes, yes. So final answer has to be in simplest form. Okay. So if you're not sure, next time if you're not sure, just use a calculator. So what's the simplest form?
1/4.
1 over 4, right? So this is the answer. Okay. So you don't have to use your mental calculation. Just use a calculator and then you should be able to get it. Clear? Okay, same thing. If you make use of the same technique, so basically let's say this is the for the simple division. Okay, so can you do the same thing for this? So do you think do you need to do anything to the first term? So let's say this is your first term, this is the second term. So do you think you need to do anything to the first term?
Open.
No. Do you think you need to do anything to the first term?
No.
No, right? Why you don't need to do anything to the first term?
The first term stays the same.
Yes, exactly. Okay. Then what about what you need to do to the second term?
Flip.
Yeah, so you need to flip it, but before you flip it, you need to change the sign from divide to times. So once you times, you need to flip what upside down, right? Okay. So whatever above 8a3 8a cube b need to come down. So whatever below you need to 32 bracket a b to the power 3. So far so good. So far so good. Okay, good. So like you said just now, you wanted to open the brackets, right? Okay, but actually the first step is not to open brackets first. The first step is to get it into times first. Are you clear? So once you get it into times, right, then now you just get rid of the bracket. In this case, right, so you have a bracket here. So can I just write it? Let me erase this first. So you have this 16 bracket a3b. So what do you think? Are you supposed to like first arrow, second arrow? Do you think you need to do like first arrow, second arrow? To open the bracket?
No.
Why no? Why yes?
Because
Mm.
the A
Mhm.
should be
Mm.
one whole expression.
Actually, your explanation is not very accurate. Okay, so in fact, right, let me give you another example. Over here, the a cube is times b, right? For the first one,
Yeah.
it's 8 cube times b, right? And over here is times, right? Okay, good. What about the second one? The second one is 16 times, but inside is plus. Okay, good. So this is the major difference. This is the major difference between these two here. Okay, so if you have a plus, right, you're supposed to have a first arrow, second arrow, and then your first arrow you will get 16a to the power of 3, and then the second arrow you will get 16b, right? And then in between is they are separated by a plus. Okay, so when you have something plus inside, right, then you need to do the arrow. Okay, first arrow, second arrow. But over here, right, it's not plus, it's also not minus, it's times. So when it's times, right, you just remove the bracket. When it's times throughout, just remove the bracket. Okay, what did I say?
If it's times throughout, just remove the bracket.
Correct. And then if it's plus or minus,
You know, open
is it plus? You have to open with open the bracket with
the arrow.
yeah, first arrow and second arrow. Are you clear? So over here, look back at this. Is it times
Yeah.
throughout? If it's times, just get rid of the bracket, just remove. What about here? Is it times throughout?
Yeah.
Okay, just remove. Okay, then now I think the question is much simpler. Okay, let me just do it on the right. But the most important thing is the first step. The first step is to change the divide to times and then flip the second function. Are you clear? So the second step is to remove the bracket because it's times throughout, so you can just remove the bracket. So let me just get it here. Okay, I just try to do it here because I have more space. Okay? So over here, you have 4, then you have a to the power of 3. A to the power of 3 means how many a times? A, 3 a's times together, right?
Yeah.
So b4, how many b?
4.
4 of them, right? Okay? 16. Can you see a3 here?
Yeah.
So how many a?
3.
Yeah, 3a. What? How many b? 1 only. Okay? Next. 32. 1a. How many b?
3.
3b. Yeah. How many a?
3.
3a. How many b?
1.
Yep. So with this, so now what you need to do, up and below, if you have the same thing, you can
Cancel.
delete. Okay, cancel or delete. So if you use a black color one, why I use black color? Because it's easier for you to see. Okay, so gone, right? So it's gone, then you just use an eraser, just erase it. Simple. Then another one. Can you see a and a?
Yeah.
Gone as well, right?
Yeah.
Okay? Then I think you can continue. Can you see this B?
Yeah.
Okay, go on next one. So you just do it step by step. How many A? 3A. 3A. Okay? You can do it like at one go. Okay? Okay? So now what you are left with on top, 4 3B's they multiply each other, 32, then you have 2B multiply each other. So it means you just do the number times number, then letter times letter. So 4 times 32, how much, what you get?
128.
128. How many B on top? 3B here, 2B here. How many B?
5.
5. So it's B to the power of
5.
5. Below 16 times 8.
128.
Oh, 128 also. Okay, good. Then how many A? Below?
2.
2. So it's A to the power of
2.
2. So can you see you have 128 here, 128 here. What can you do?
Cancel.
Cancel, right? Right?
Yeah.
So once you cancel, so you end up with
B.
B to the power of 5
Over
over.
A square.
Yes. So that's the answer. Is it simple or not? Is it simple? Is it simple or is it very hard?
Normal.
Normal, right? Manageable, right? Yeah. So actually the key to do this question is to change the equal sign to the times, and then at the same time, once you times, you need to flip. Are you clear?
Yeah.
So with this, can you do this question A? Because I see A is very similar. Can you just do it? Use a blank page. Okay, yeah, I will go through it here. By the way, the lesson is live, I think. Let me just check. Hello? Hello, hello? Hello? Yeah, the lesson is live. Yeah, wait. You just get the question. You just use a blank page. Just do it. Yeah. So over here is divide. So change it to times first. You have to do it step by step. Okay, so if you see opportunity to cancel, cancel. Okay, then cancel means use an eraser, erase it. And then if you can use the calculator, please use the calculator. Okay, so follow every single step. And if you are done, just let me know. I ask you to bring the table here later, after this question, so that I can easily just turn the table and see your screen. You shouldn't take very long, because this question is very simple. Done? Bring the table closer. Okay. Okay, so the first step is to, what is supposed to be your first step? Times, right?
Yeah.
Okay, good. So that means just don't change anything for the first term, but the second one just flip it. Did you do this? First step?
Yeah.
The second step is to just, there was no bracket for you to open, right?
Yeah.
Then you only have what? You only have the x to the power of 3. You just split the x to the power of 3. You split to? Did you split? Yeah, split to 3x, right? Then below is how many y? 3y also, right?
Yeah.
Did you do this? Yeah, good. Then above, how many y?
4.
4, yeah. Below, 1x, right?
Yeah.
So with this, I think you can see that you have 3y here, 3y here, then you can cancel them, right? Right? Am I right? Am I right or not? Right or wrong?
Yeah.
Then you have x. Okay, then done. 5 times 49 来 5 times 49
245.
245 2x, so x to the power of 2 y. Below 7 times 25
175.
什么
175.
175. Okay, so I still see opportunity to reduce the 245 and 175. Can you use a calculator and what do you get? 7 over 5. What is on top?
X.
X squared and y. Did you get this?
No.
Why not? Which part is wrong? Can you not see the x and the x? Look at the question just now. What have I done here? What have I done here? What have I done here? Quick, don't waste my time. What have I done here?
Cancel.
Cancel what?
Similar.
Yeah, if they are similar, just cancel. Up and below. Right? Right or wrong? If you don't cancel, you expand them for what? Why you expand them? Tell me. Why you expand them? If you don't cancel them. For fun, is it? You expand them is for you to what?
Cancel.
For you to see and
Simplify.
cancel accordingly, right?
Yeah.
You can count, right? You can count, right? How many y below? 1, 2, 3. How many y above? 4. So you can only cancel 3. Then above also cancel?
3.
Yes. How many x on top?
3.
How many x below?
1.
So how many you can cancel?
1.
Exactly. And then after that, once you get this 245 and 175, you need to use the calculator to check whether it's the simplest, right?
Yeah.
I just talked about it just now, right? Now let's say you end up with 3 over 12. So similarly, you end up with 245 over 175. Do you stop here?
No.
Why not?
You know, simplify
Simplify what?
the fraction.
Which fraction?
The 245.
How do you simplify the fraction?
It type inside the calculator.
So yeah. So you get. So this is the final answer. Are you clear or not? Okay? Good. Next. Okay, so there are 3 formulas I asked you to memorize. Which 3? Do you even know how to? Do you even know where to refer? Do you even know where to find the 3 formulas? Answer my question. I asked you to memorize. Did you take down somewhere? Yes or no?
I think so.
Okay. Then what are you waiting for? Last lesson, I asked you to memorize 3 formulas. Quick one, don't waste my time. You don't let me see your materials like 5 years ago or 3 years ago. I don't want. Last week, 3 formulas. Yes or no? So I asked you to memorize, then you never even like write it down. Then you memorize what? You memorize thin air. You memorize emptiness. Have or don't have? Have or don't have?
Yeah, I found this.
So what is this?
Proportional.
So do you think this is the one I asked you to memorize? Do you think this is what I asked you to memorize? Just answer fast. Don't waste time. Yes means yes. No means no. Hello. You got take down or you never take down? It's a very straightforward answer. No means no, yes means yes. Yes, then show me. If cannot show me, that means no. Simple as that. Hello.
No.
No. Okay, good. So if I ask you to memorize and you never take it down somewhere, then how do you memorize? You memorize what? You memorize what? By the way, when I give you something, I ask you to memorize. So let's say I never give you time to write down. You can say, hey, please give me time to write down. Or you can write down write down the materials during the break, the 5-minute break. Or you can even write it down after our lesson. But you need to write it down somewhere. Okay? Things I ask you to memorize, you should what?
Memorize.
But before you memorize, what you need to do? Before you memorize, what you need to do? Can you answer straight away?
Write it down.
Where? Okay. It's only when you write it down, then you get to memorize them, right? Make sense? Make sense? So I give you one more chance. These are the 3 formulas you need to memorize. I'm not going to give this to you again and again and again next time. And I give you these 3, and you better write it down correctly. By the way, I'm talking about these 3, not this one. This one is the answer. This one is the question. 1, 2, 3. Done? Double check. Make sure you have copied correctly.
Yeah.
Let me also check on it. Hey. Okay. Can I ask you what's the difference between the first and the third one? You tell me. What's the difference between the first and the third one? Are they the same?
No.
Why not? First one and the third one. Why they are not the same?
The one has like a bracket.
Okay, there is a bracket here, right?
Yeah.
Then the first one?
The first one doesn't have a bracket.
The first one doesn't have the bracket. Okay? And then what about the square for the third one?
The one only has like one.
And the square is
It's
out of the...
outside the bracket.
Yes. Then what about the square here?
The A has a square. The B also has a square.
Yes. Okay? So the first one and the third one, are they the same or they are different?
Is it different?
Yep. They are very different. They are very different. Okay? So now, if you look at this, so 9x squared, if you split, so I'm talking about the numerator first. Then later we talk about the denominator. So when it comes to questions, this kind of question, right, it's always, you need to do something to the numerator, you need to do something to the denominator. Same thing. Over here, right, can you see? You need to expand the numerator, right?
Yeah.
Right? You need to expand the numerator, right?
Yeah.
Same thing. You need to expand so you need to expand the numerator, right?
Yeah.
That means you try to expand as much as possible. Right?
Yeah.
Why expand? Why you want to expand?
To cancel.
Yeah. Expand to see if there is an opportunity for you to cancel. Right? Because if you can cancel, that means it simplifies your question a lot, right?
Yeah.
Okay, good. So that means whenever you come to simplify question, can you see the word simplify? Can you see the word simplify? Can you see the word simplify here? When you come to simplify question, and then if they give you in this, you always need to do the numerator, see if you can expand. And for this one, see if you can expand. Okay? Or factorize. Okay, so how do you expand 9x squared? 9x squared minus 1. How do you expand this? How do you split 9? Right? How do you split square?
X.
Right?
Yeah.
How do you split 1? 1 times 1, right? By the way, 1, if you split it, is 1 times 1. Why you must split it? because if you don't split it, 1 is 1, this is not splitting. 1 is 1, this is not splitting. What is splitting? It must split to 2, yes. So you have to write in 1 times 1. Are you clear? That's why I split the 1 into 1 times 1. Alright? And then in between there is a minus sign, right? Okay, good. So with this, I think my job is half done. Why? Can you see that you have 3x, you also have 3x? Can you see that? Can you see that?
Yeah.
So basically, right, this one, if you so-called you do it in another way, is the 9x squared, right, actually is equal to how many 3 you have? How many 3 you have here? 2. So it's 3 to the power of 2, right? How many x you have?
2.
So x to the power of
2.
Okay, good. Over here, how many 1 you have?
2.
Right? So there's a 1 square, right? So once you reach this step, can you see that 3 to the power of 2, x to the power of 2, they are actually 3x bracket 2. And then 1, 2. Can you see that? Can you see that?
Yeah.
So once you have this, can you see the similarity between this and this one? So what do you get? Compare. So you write this formula. This is one of the formula you need to memorize. So you write a squared minus b squared is equal to a plus b, a minus b, right? So how do you write above? What do you think? Match. So 3 a plus b. So what you get above?
Plus
3
3x
3x
square.
Square. A plus b.
3x plus 1
Yeah.
square.
Square?
Oh,
Any square?
1
Is a plus b leh?
1
Huh?
1
What do you mean by 1?
plus 1.
There plus 1 done already. Wait, what is this?
A plus b.
A plus b. Any square?
No.
Any one? A plus b, So once again, what do you get?
3x plus 1.
Next, here. Here's a minus b. What is here?
X
Uh-huh.
minus 1.
Anything else?
No.
Why not? Why don't have a square?
There's no square.
Yes. Over here no square. So you just follow the pattern. Okay? So that's what you should get for the numerator. Okay? So after we do the numerator, now we need to do for the denominator. So next time when you do this kind of question, always write the formula below so you can match. So once you match, you just fill in the pattern accordingly. So how do you get 6x squared? By the way, this is a 3 term. How do you get 6x squared?
3
3x times
2.
2x, right? Am I right?
Yeah.
Minus 1, right?
Yeah.
So minus 1 can be what? Can be minus 1 times 1, right? Can be 1 times minus 1 also, right?
Yeah.
But only these two possible answers, right?
Yeah.
So I test the first one first. I test this one first.
Yeah.
So if I test this one without any sign, it is?
Plus.
Yes. So I test this one first. So how I test? Can you continue from here? Open the bracket. Show me. first. Okay. Once you are done with use a calculator. Hold on. 3x, 2x is 6x. How many x you have for the first term? Yes. Remove this mistake. Now you go and underline similar term, then simplify. So do you get, is this the same as the question? What's the question? The question is this one. Is it the same? Is it the same?
Yeah.
So they are the same, right? So when they are the same, that means this is correct. I mean this choice is correct. Okay?
Yeah.
So if this choice is correct, then you can continue. Hold on, So that means that this choice is correct. So if this choice is correct, then you can continue. How? That means this one is also correct. Okay? So this one is correct. That means now, okay, so just now when we do 9x minus 1, right? We end up with what? We end up with this one. Okay? Then now, the 6x squared plus x minus 1, right? We end up with this one. Okay? So now, we need to use this. So this one, you change to this one already. Okay? And now, this one, you change to this one already. Okay? So your job is to use the changed or the transform with the transform answer. Okay. So 9x squared minus 1, I transform to this one already, right?
Yeah.
So I write 3x plus 1, 3x minus 1. This one, 6x squared plus x minus 1, I transform to this one already, right?
Yeah.
I write the transform one. Any similar term that you can delete? Answer me. Like top and below. Any similar term that you can delete? This one, right?
Yeah.
So if they are the same, you can
Cancel.
cancel. So when you cancel means you use an eraser. I mean, if you do it on a tablet, then you can use an eraser. So you end up with this one. Are you clear? Can you delete further?
No.
Why not? I thought I see a +1. I see a +1. They're the same.
It's together.
Yes, they're together. They are together, okay? Okay? So that's the final answer. Okay? Can? Good. Alright, then of course, then we move on. This question. How come you never do this? All empty. 为什么? No idea, is it? No idea what to do. 1 mark, 1 mark. Oh. I never see. What? I don't know how to do. Answer my question. Rational number, what integer? Any idea? Yes or no? Have you learned? Yes or no? Just answer straight away.
Got learned.
Got learned, but long time ago. What?
Yeah.
Cannot remember already.
It was in Sec 1.
Okay, good. Never mind. So now, please, you are in Sec 2, so whatever you have learned before Sec 2, you'll be tested. You are expected to know anything before Sec 2. So let's talk about the real numbers and then of course rational number. Okay, so first thing first, we start with real numbers. So I'm expecting you to remember this. I call this the mathematics universe. Okay? What are you looking at? Huh? What are you looking at? I asked you to look at this one. Okay. I expect you to remember this mathematics universe. You start with real number. Okay? Real number. So when you start with real number, then I think I have the picture here. Let me open this. Yeah, punching. Good. So let's see that. I don't know where is it. The funny thing. Yeah, here. Okay, good. So real number means everything. Okay, everything is real numbers. Okay, then after the real number, you branch out to rational number. Irrational number. I hope you know that irrational numbers, they are opposite to rational numbers. Does it make sense? Relevant, irrelevant,
Yeah.
they are opposite to each other, right?
Yeah.
Okay, so let's start with what are irrational numbers? Square root 2. Can you punch your calculator with square root 2? Just read the whole string to me slowly. 慢慢来 1 point
1.4142
Okay, good enough. Okay, non-stop, right?
No, that's it.
I think because your calculator can only take 9 digits, actually it's non-stop. Okay, actually it's non-stop, but just that your calculator has limitation. It can only take maybe 9 digits. That's why it stopped. Okay, so okay, can you key in pi? Tell me the value.
3.16 or something.
Yeah, you give me all.
3.141 26 54.
No more already, right?
Yeah.
Due to the limitation of your calculator. Actually, it goes on and on and on. Okay? So, these are rational numbers. Number one, it goes on and on. Goes on and on. Is there a pattern or not? Is there a pattern in their decimal number?
No.
No pattern, random. Okay? Does it make sense? So that means if you have a number and then you get it into the decimal number, and if the number it goes on and on plus is random, then it's a irrational number. Does it make sense? So it's very easy to memorize irrational numbers, right? Then what about rational number? So for rational number, you have a few fraction. Okay? You have integer. Okay? Okay. And then you have this. Okay, decimal number. Okay, can or not? So for decimal number, I give you a few examples. 0.345. Stop. Okay? And I give you another one. 0.3. Do you know what is 0.3 with a dot on top?
No.
If 0.3 with a dot on top, right, is a short form. It represents 0.3333 non-stop. Okay? Then can I ask you, how is this one 0.33333 all the way different from irrational number? Because 0.3 with a dot on top is rational number. How is this different from the irrational number?
Because
Mm.
the 0.31
Ah.
the numbers are like the same
Yeah, same. That means they have a
pattern.
yes. Then wow, this one
It's random.
correct. So how you know how to differentiate now? Okay, good. Integer. Okay, let's not talk about integer. But fraction. You know fraction, right? 2207 is a fraction, right? Right. 1/3 is a fraction, right?
Yeah.
Anything with a fraction huh? Okay. Then integer. Integer you can branch out. Zero. Okay. Then you have positive integer. And then you have negative integer. So negative integer minus 2, minus 3. Okay? Okay?
Is the can only be times by one number.
You are talking about which one now?
The integer.
Which integer? The negative or positive?
Both. Because there's one that can only be times by one number.
No, minus 4. I'm not talking about prime number. You're talking about prime number already. Okay, we don't talk about prime number. We're talking about integer. So positive integer 11, 14, 122. These three are positive integers. Okay? So that's it. You have to memorize this. I mean, you have to kind of like, I think it's pretty easy to memorize because irrational number is what? It goes on and random. Easy, right? Then for the rational number, decimal, integer, and fraction. Fraction is very easy, right? Fraction is a fraction, right? Decimal number, very easy also.
Yeah.
Got pattern and decimal number, right? Integer also very easy. Positive, 0, and negative. Okay? Right? Negative means must be negative, right? Then can I ask you, negative 2.2, this one is integer or fraction or decimal number? So what? So this negative 2.2 is rational number, fraction, integer, decimal number, or irrational number? Just look. Imagine which one. Can it be this? No. Okay. Why not?
Because irrational, the number is random.
Huh? Random and
And it goes on.
and on, right?
Yeah.
This one goes on and on or not?
No.
No. Okay, good. So this one out. No. So this one is definitely not irrational already. Does it make sense?
Yeah.
Then what about decimal number? Okay, can it be a fraction or not? This one, is it a fraction? Minus 2.2, is it a fraction?
It didn't give as a fraction.
Yeah, so it's given as a
Decimal.
decimal. So fraction also not likely, right? Not likely, right?
Yeah.
Integer? No leh. Integer is always 11, 40, 1, 2, 2, minus 2. So that means there's no, for integer there is no decimal number one, right? So it's also not integer. So the most likely one is the decimal number lor. Does it make sense?
Yeah.
Does it make sense?
Yeah.
Okay, good. So this is a decimal number. Okay? So with this understanding now, can you take a look at the question? Okay, one by one. They want integer, right? Then answer yourself. Out of this, which one is the integer? Minus 1.23. What number is this?
Decimal.
Write down lah. Just right below. So basically, before you answer this question, you need to draw this map. By the way, this map is very easy. Then square root 2 lah. Why irrational?
Because the number. It goes on
And
and on
and
and it's random.
yes. 3. Yes. Pi leh? Why irrational?
It's the same as
Okay. Then 1 and 4, 7. Do you consider it a fraction or do you consider it a rational number? 1 and 4 over 7. You look.
fraction.
Yeah. Okay, so answer the question. Integer. Which one is the integer? Rational number. Look, rational number also include
Fraction. Integer. And decimal.
okay. So that means if you see fraction, integer, decimal number, they are all
Rational.
correct. Yeah. So pick. Does it make sense? Irrational numbers. Is it easy? But before it's easy, you must get this down. What are you waiting for? Okay? Alright, so yes, so that's the first half of our lesson. So let me just stop streaming. Then let me save this first.